Here are some qualities that people often mention when they talk about Java. Simple, safe, platform independent, rich library, and designed for the internet. These qualities really need to be put into context to be understood. An application that's written using traditional high-level language like C or C++ is developed like this. First, the programmer writes the code. Then the code is compiled, which turns it into low-level instructions that the processor can understand. When the application is run, these instructions are loaded into memory and executed by the CPU. And that gives you a working program. With Java, there's an important difference. Java programs are also compiled, but instead of translating the high-level code into machine language, the compiler translates it into Java bytecode. When a Java application is run, the first thing that happens is that a second application starts up. This second application is called the Java Virtual Machine, or the JVM. In the case of a Java program, the JVM reads the bytecode and then sends the appropriate instructions to the CPU. And this is how you get a working program in Java. So why this extra step for a Java program? Well, there are really two reasons: safety and portability. The JVM gives you extra safety because it makes sure that certain bad things don't happen. For example, the JVM won't allow a Java program to access memory that it should not have access to. With a C program, invalid memory accesses can happen, and when they do, they can cause security problems. In addition to safety, the JVM gives you great portability. Oracle only needs to release 3 JVMs, one for each major platform: Windows, Unix, and Mac. And they can be confident that a Java application written on one platform will run the same way on all of the platforms. If you try this with a C program, you have to recompile the entire program for each specific platform. And if you don't have all the necessary libraries or links, then your compilation could fail. The inclusion of a really rich collection of standard libraries in Java is another thing that makes Java so portable. There are over 4,000 classes in the standard Java API in Java 8. By the way, API stands for Application Program Interface. These are the documentation, the Java docs, for the classes in the Java Standard Library. But people often use the term to mean the documentation and the underlying classes they refer to. In this diagram taken from the Java tutorial, the JVM and API together make up the Java platform. The Java platform is what sits between your Java program and the hardware platform you're running it on. Okay, now I have a question for you. If the JVM gives you great properties like added safety and platform independence, then why don't all programming languages take this approach? Another way of asking this question is there a downside to having a JVM? Take 5 seconds to answer this question, starting from now. The answer is yes, there's actually an obvious downside. Because you have something in between your bytecode and your CPU, the application is necessarily going to be slower and less efficient than an application that has nothing between the machine code and the CPU. In most cases, this decrease in performance will not actually be noticeable, but sometimes it will. For example, in low-level applications like operating systems and device drivers, you don't want to have any decrease in performance if you can help it. Likewise, in systems with limited resources like embedded software, you may not have the memory to run an extra application like the JVM. So let's revisit the good qualities that Java programming language gives us. It's simpler than a language like C because Java does the memory management for you. On the downside, when you need fine-grained control over memory, you can't do that in Java, so you have to use a language like C. Because of the JVM, Java is safer and more platform independent than other languages. These two properties are considered by Horstman to be the most important qualities of the Java language. The Java language comes with a rich library and excellent online documentation for that library. If you ever need to know what a Java class does, just go to Google and type Java API in the search box. The first hit will take you to the Java docs for the standard library. Finally, Java was introduced at a time when the internet was first starting to take off. So the Java language designers and the Java library designers could incorporate features and components that were informed by internet trends. Here's a table of important Java releases. Let's see how much you know about the Java language already. From a programmer's point of view, specifically from an ease of use perspective, can you tell me which of these releases was the most important? There's one that stands out above all the rest. I'll give you 5 seconds starting from now. Java version 5 is the answer. Version 5 introduced generics, and generics was probably the most important thing. But it also introduced the enhanced for loop, auto-boxing, enumerations, and even more than that. Now, version 1.2 was also pretty important because it introduced swing and the swing libraries and the collection libraries. And believe it or not, a lot of Java programmers think that version 8, the version that was just released in 2014, will turn out to be one of the most important because it introduced something called lambda expressions. Now, we're going to talk more about lambda expressions in one of the later sessions in this course, and you can decide for yourself how useful you think they are. And here's just the most significant Java releases highlighted in red. Okay, now let's take a look at some basic Java code. The first thing you need to know about Java is that everything in Java has to be part of a class. This particular class has the name Hello World App. Now, Java is case sensitive, and there are 3 words in this class name. There's no spaces. Java doesn't allow spaces in identifiers, and each word is capitalized. And this way of writing names and identifiers is called camel case capitalization because the capital letters might remind you of the humps on a camel. By convention, Java uses camel case for most identifiers. For class names, which are also the names of types, the first letter is capitalized. For variable names and method names, like the method main here, the first letter is not capitalized. Though if there were more than just one word in this method name, the subsequent words would be capitalized. The package name should be in all lowercase letters. And constant names, there are no constants in this code, by the way, will be in all caps with words separated by an underscore. Let's highlight some of the portions of this code. The main method of a class is special because it can be invoked from the outside of Java. If you compile and run this Java class, it is the main method that will be invoked. And this main method will, as you might have guessed, print the string hello world. There are 2 javadoc comments in this code. Javadoc comments start with a slash and 2 stars. Normal comments start with a slash and 1 star. Or they may start with 2 slashes if they're just single line comments, like the one you see here saying display the string. An algorithm is a sequence of steps that is unambiguous, executable, and terminating. When I'm trying to describe what an algorithm is to someone who doesn't know anything about programming, I usually just say that an algorithm is simply a recipe. You got your ingredients, which is basically your input, and you simply follow the instructions precisely. And of course, there's an end product, like a cake or a casserole or a nice hot bowl of soup. Here's an algorithm for deciding between 2 cars to purchase. For each car, you calculate the yearly fuel cost. Then you use that to calculate the yearly operating cost. Then you multiply that by 10 to get the total operating cost for the life of the car, which presumably the life of the car is 10 years here. Then you add the operating cost to the purchase price and get the total cost of ownership. Once you've done that for both cars, you compare the total cost of ownership for each car, and then you buy the one that's less expensive. Now, this is an algorithm. It's a sequence of steps that's unambiguous, executable, and it terminates. You may or may not think this is a good algorithm for deciding on which car to purchase, but the important thing here is that it is an algorithm. This reminds me of the old joke about the computer scientist who died in the shower because he followed the directions on the shampoo bottle that read, shampoo, rinse, repeat. And I guess he died because there was no terminating conditions on the instructions, so he kept repeating the steps forever. Now, of course, this joke is nonsense because any real computer scientist would quickly be able to see that the steps were non-terminating and therefore that the instructions did not constitute a proper algorithm. Okay, so with that little life lesson, we'll conclude this video. In the next video, we'll look into types and variables in Java.